Alright, let us see the next question. Determine whether the following signal is energy or power signal and calculate the energy or power. And given x of t is equal to cos t. Fine. Before starting the mathematical steps of this question, let me tell you that there is a just thumb rule for determining this. If the signal is a periodic signal, then the signal may be power signal, and if it is non-periodic, maybe it is energy signal. Okay, I have used the word maybe. It is not always sure, but this is a thumb rule. If the signal given us a periodic signal, then it may be power signal. So x of t equal to cos t is clearly a periodic signal, so it may be a power signal. And what is power signal? A power signal is a signal whose average power is finite. So if any signal is having its average power as finite, then we call it as a power signal. Okay. And for a power signal, that means power is finite and its energy will be infinite. Okay. Now let us see whether this is a power signal or not. So let us first find the power of the signal. What is the equation to find out the powers of a signal? Power is given by 1 by time period integral over one complete time period 0 to t x square of t dt. This is the expression to find out the average power of a signal. Okay, so our signal x of t is equal to cos t. So before putting this into this equation, we need to find something. There's nothing but the time period. Okay, what is the time period, or how can we find out the time period? The time period is nothing but we have to know the general form of a cosine signal or sine signal, that is given by x of t is equal to a cos omega t, if we are ignoring the phase. Okay, a cos omega t. So what is omega? Omega is the angular frequency. So whatever you find as the coefficient of t inside the cosine, okay, whatever you find as the coefficient of t inside the cosine, that will be your angular frequency omega. Okay, now let us come back to our signal. X of t is cos t. What is the coefficient of t? It is 1, right? Cos t is cos 1t. Okay, so omega is clearly 1. Okay, omega is clearly 1. Now what is time period t? Capital T is 2 pi by omega. Okay, here it is 2 pi by 1. That will give you 2 pi. So t equal to 2 pi. Now let us evaluate this expression very easily. So average power will be 1 by time period is 2 pi, as we have obtained right now, integral 0 to t, or integral over one complete time period 0 to t. This can be 0 to, instead of 0 to t, we can write it as minus t by 2 to plus t by 2 also. That will give you the correct answer. Okay, so in this case, let us take 0 to t or 0 to 2 pi. And what else is there? It is x square of t dt. Okay, x square of t dt. So x of t is cos t. So x square of t dt is cos square t dt. Fine. Now it is only a matter of integration. That is given by 1 by 2 pi into integral 0 to 2 pi. Instead of cos square t, I know it is 1 plus cos 2t whole divided by 2 dt. Okay, that is 1 by 2 pi or 1 by 4 pi. I can write it as 1 by 4 pi. 2 is taken outside the integral, so 1 by 4 pi integral 0 to 2 pi dt plus integral 0 to 2 pi cos 2t dt. Okay, that is 1 by 4 pi. What is integral dt? It is t within the limits 0 to 2 pi plus What is integral cos 2t? Integral cos 2t is sine 2t whole divided by 2. Again within the limits 0 to 2 pi. Okay. So this is 1 by 4 pi into, applying the upper limit you will get it as 2 pi, and applying the lower limit which gives you the minus 0. So 2 pi is still there. So 2 pi plus, what about the integration, or what about the limit application in the second term? It will give you sine 4 pi minus sine 0, that is 0. Okay, so the final answer is 1 by 2. Okay, so we got the power, average power as 1 by 2. So that is a finite value, right? So power as finite. Okay, so our assumption is more and more stronger. Now we have to find out the energy of the signal also. Alright, let us find out the energy of the signal also. We got power as 1 by 2 in the previous steps. Now we have to find out energy. So what is the expression to find out energy? Energy is integral over minus infinity to plus infinity mod x square of t dt. This much. Okay. So this is equal to, from our signal, it is integral minus infinity to infinity x square of t is cos square t dt. That is integral minus infinity to infinity 1 plus cos 2t whole by 2 dt. That is t or t by 2 from minus infinity to infinity plus cos 2t by 2, again from minus infinity to infinity. We don't need to do anything further, because the first term itself will reveal you that the answer is infinity. Okay, so consolidating what we have obtained so far is the power, average power of our signal is 1 by 2, which is a finite value, and the energy of our signal turned out to be infinity. So clearly our signal under inspection is a power signal. Okay, so I can provide some thumb rules here. Whenever you get a cosine signal or sinusoidal signal in the form a sine omega t or a cos omega t, first point to be noted is the power, average power of that signal will be always a square by 2. Okay, where a is the amplitude of that signal, right? And the second thing, a sinusoidal or cosine signal will always be periodic, and therefore it will be a power signal, not energy signal. Okay, so our answer to this question is the signal is a power signal, and the average power is 1 by 2. Okay, we will jump to the next question. Mathematically analyze the following system for stability and causality. Given h of n equal to a raised to n u of n for mod a less than 1. Okay, first we will start with the stability check. How will you check whether a system is stable or not? It is very simple. A system is stable if sigma n equal to minus infinity to infinity h of n, mod h of n, will be a finite value. If the summation of the impulse response or system response is a finite value, or in other words, if the system response is converging, then we can say the system is stable. Okay, so here h of n is given as a raised to n u of n, and mod a is less than 1. Okay, now let us find out what the summation of impulse responses. Therefore, sigma over n equal to minus infinity to infinity h of n is a raised to n u of n. Okay, this modulus is meaningless because it is a real signal. So this summation will be equal to, you don't need to summate this from the entire minus infinity to plus infinity. No need, because a raised to n is multiplied by u of n. Okay, So this can be reduced as sigma n equal to 0 to infinity a raised to n. Okay, this signal a raised to n is multiplied by u of n means the signal exists only in positive n axis. So sigma n from 0 to infinity a raised to n. Now what we can do is just expand this sigma. So you will get a raised to 0 plus a raised to 1 plus a raised to 2 plus etc., and it goes to infinite terms. Okay, so clearly this is a GP, right? This is a GP with the first term equal to a raised to 0, that is 1, and the common ratio equal to, what is common ratio? Common ratio means any term divided by its previous term. Okay, so common ratio is here a itself. Okay, so this is an infinite GP. This is an infinite GP with first term as 1 and common ratio as a. So what is the summation of an infinite GP? We have a result here. Summation of an infinite GP is equal to a by 1 minus r, where a is the first term, r is the common ratio. Okay, so applying this equation here, what you will get is a by 1 minus r. A is 1 divided by 1 minus r is still a. Okay, you have to remember that we can use this equation only if the common ratio r is less than 1. Only if common ratio less than 1. And can we apply it here? Of course we can, because the question clearly says that mod a less than 1, because here r is equal to a. Okay, therefore mod r is less than 1. Okay, so 1 by 1 minus a is the answer to this summation. And we are actually not interested in the final result, but we are just interested whether the summation converges or not. So 1 by 1 minus is definitely a finite value, so we can say that this is less than infinity. Therefore the system is obviously stable. Okay, so that is how we test the system for stability. Now let us check how causality can be tested. Test for causality. And what is causality? A system is said to be causal if its impulse response is strictly right-sided. Okay, the impulse response is right-sided, then it is causal. Otherwise it is non-causal. Non-causal is actually, okay, non-practical. Now let us see what h of n is. Causality can be clearly judged by viewing the signal graphically. So how can you graphically view this system response h of n? I can always draw it in graphical form if you have a thorough understanding about signals. Okay, let me illustrate. What is actually a raised to n? A raised to n and a raised to n. Okay, I'm just calculating or drawing a raised to n alone, provided mod a is less than 1. So a raised to n is actually the exponential signal, right? Where mod a less than 1 means it is a decaying exponential. So this is a discrete signal with decaying exponential. Like this. Goes to infinity to both the sides. Okay, so this is a raised to n. Fine. And what is a raised to n into u of n? If you multiply this signal with u of n, the resultant will be having values only from n equal to 0 to the positive side. The all other values in the negative x-axis will be gone, will vanish. Fine. So this is a raised to n u of n with the mod a less than 1. Okay. Now clearly this signal, which is our impulse response, is right-sided. It does not have any single value which is in the negative n axis, time axis. Okay. So since there are no samples in the negative time axis, the system is causal. System is causal, or it can be practically realized. Okay, so this is how stability and causality can be analyzed. Let us put up with the next question. An LTI system has the impulse response h of n given u of n minus u of n minus 3. Find the output of the system to the input x of n equal to 1 by 3 raised to n u of n. So as per the previous problem worked out in a previous video, this question also makes use of the convolution sum equation, which is given by y of n is equal to sigma over k equal to minus infinity to plus infinity x of k into h of n minus k. And what we are going to do is realize this equation. So we need to find out x of k, we need to find out h of k, then h of minus k, and ultimately h of n minus k. Then find the product x of k into h of n minus k, and finally summate all the samples. So the first step is to draw x of k. X of k is very easy to draw because we have x of n here. Just change the index from n to k. Okay, I'm drawing x of k. X of k is 1 by 3 raised to k into u of k. Since there is a multiplication with u of n coming, I think there will not be any samples in the negative k axis. Okay, so we have only n positive samples. So this will be x of k. Starts from 0, 1, 2, etc. and goes to infinity. Next, I will draw h of k. So h of k is simple to draw. It is given by u of n minus u of n minus 3. So it will be having samples at n equal to 0, n equal to 1, and n equal to 2. So u of n minus u of n minus 3 means n equal to 0, k equal to 0, 1, and 2. Okay, all other samples will be lost, 0. So this is h of k equal to, so n is changed to k, u of k minus u of k minus 3, and all samples are 1. Okay, now what we have to do is we have to find out h of minus k. I'll draw it for you. And so this is h of minus k, which is obtained by flipping h of k about the y-axis. Okay, now from the main equation, what we have to find out is h of n minus k. And how will you find out h of n minus k? H of n minus k is nothing but h of minus k shifted to n units. If n is negative, then shift this n unit by left, or if n is positive, then shift n units to the right. Okay, so since x of k is an infinite signal, we will follow this procedure. First, find out h of n minus k for n very large negative number. Okay, so let us see how is h of n minus k for n very less than 0. That means we have to shift h of k to the far negative side. So this will be h of n minus k when shifted to far negative side. And this sample will be at n, and this sample will be at n. This is at n minus 1, this is at n minus 2. Ready? Because h of minus k was starting from n equal to 0, k equal to 0. So h of n minus k means it is shifted n units from 0 to the left. So the starting sample will be n. Okay. And now let us look at the parent equation. it should multiply x of k and h of n minus k. We have x of k here already and h of n minus k for n very less than 0 is ready. What is the product x of k into h of n minus k? It is absolutely 0, right? So this is equal to 0 in the first condition, right? Now the point to be remembered is that when you increase n to the positive side, what happens? This h of n minus k, this sample comes closer to the y-axis, right? Closer to the origin. Fine. And if n is slightly positive, what happens to the product x of k and h of n minus k? It still remains 0, right? And if I keep on increasing n, till what value of n, this y of n becomes 0. Obviously, y of n becomes 0 until this n becomes less than 0, right? Until n becomes less than 0, these two signals x of k and h of n minus k never coincide, so the product is 0. Okay, so we can write that y of n equal to 0 for n less than 0. Okay, now what is the next condition? Next condition is we keep on increasing n value, then what happens? At some point, this first sample, right, this first sample of h of n minus k gets moved on and just coincide with x of k here, but the last sample will be out or will not be coinciding with x of k. So that is the next condition. I will draw that for you. So this could be the graphical representation of the second case, where the first sample will be coinciding with x of k, but the last sample will not be coinciding with x of k. So it will come like this. So n will be here, but the last sample n minus 2 will be out of x of k. So we can immediately write that condition as n is greater than 0, but n minus 2 is less than 0. 0 was here. Okay. So n greater than 0 and n minus 2 less than 0. That implies n greater than 0 and n less than 2. Or in other words, 0 less than or equal to n less than 2. So this is the next condition to be evaluated, where y of n to be evaluated. And what is y of n at that case? Y of n is equal to sigma over do we need to sum it from k equal to minus infinity to plus infinity? No, because we need only to sum it from k equal to 0 to k equal to n, because less than 0 the sample values will not coincide, so the output will be 0. Okay, so sigma k equal to 0 to k equal to n. Then what is x of k? X of k is given as 1 by 3 raised to k. So 1 by 3 to the power k into what is h of n minus k? H of n minus k is 1. The sample value is always 1. Okay, so into 1. What will be the answer? We have to expand this summation. So the first value is 1 by 3 raised to 0, that is 1, plus 1 by 3 raised to 1, plus 1 by 3 raised to 2, plus etc. up to 1 by 3 to the power n. And this is clearly a geometric progression. This is a GP whose sum of n terms is given by, I think I can write it here, sum of n terms of a GP becomes a into 1 minus r to the power n whole divided by 1 minus r, where a is the first term, r is the common ratio, and n is the number of terms. So substituting, what is the first term? First term is 1. So 1 into 1 minus, what is the common ratio? Common ratio is 1 by 3 divided by 1 becomes 1 by 3. So 1 by 3 to the power, how many terms are there in GP? There are obviously n plus 1 terms. So n plus 1 whole divided by 1 minus 1 by 3. 1 minus 1 by 3 is 2 by 3. So this becomes equal to 3 by 2 into 1 minus 1 by 3 raised to n plus 1. So the output y of n in this condition is 3 by 2 into 1 minus 1 by 3 raised to n plus 1. What was the condition? The condition we obtained was 0 less than or equal to n less than 2. So y of n equal to 3 by 2 into 1 minus 1 by 3 raised to n plus 1 in this interval. Alright, the next case is what happens when we further increase n. If we further increase n, h of n minus k will further move to the right. So the next condition is the first sample which starts at n. In the next case, if we further increase n, h of n minus k further moves to the right. So the first sample which had already been coincided with x of k will remain there. And additionally, the last sample which was at n minus 2, now this n minus 2 is also coinciding with x of k. Okay, so this will be h of n minus k for the new condition where n minus 2 is also greater than 0. So this is the new condition, n minus 2 greater than 0. That means n greater than 2. Okay, so we are going to evaluate y of n for n greater than 2 as the next case. So what happens is y of n will be equal to sigma over, what is the limit of summation now? The product of x of k and h of n minus k will have valid values only at these three samples, n minus 2, n minus 1 and n. Okay, so the summation will be from k equal to n minus 2 to k equal to n. No other sample will produce any output because it is going to be 0. So x of k is 1 by 3 raised to k into h of n minus k is 1 always. So this is equal to, I can expand this summation by putting the first sample value 1 by 3 raised to n minus 2 plus 1 by 3 raised to n minus 1 and last value is 1 by 3 raised to n. And this is actually equal to, I can take out 1 by 3 to the power n from all the terms, making it common. So 1 by 3 raised to minus 2 plus 1 by 3 raised to minus 1 plus 1 by 3 raised to 0 is 1. Okay, so that is equal to 1 by 3 raised to n plus 3 square plus 3 plus 1 which will be equal to 1 by 3 raised to n into, this is 13. So this is 13 into 1 by 3 to the power n. That is the answer for y of n, which was our interval. Our interval was n greater than or equal to 2. Okay, so we can consolidate all the answers. So for y of n will be equal to 0 for the first case where n greater than less than 0, then 3 by 2 into 1 minus 1 by 3 raised to n plus 1. That was the second case where 0 less than or equal to n less than 2 was obtained. And the last case is 13 into 1 by 3 to the power n where n greater than or equal to 2. No other condition arises here because while we further increase n or shift h of n minus 0 to the positive, this condition never changes. Still n is greater than 0 and n minus 2 is also greater than 0. There is no any changes in the limits. Okay, so this is the final answer. We will go on with the next question. Derive the relation between correlation and convolution between two sequences. Find the cross correlation of two finite length sequences given x of n and y of n. So this question has got two parts. First, we have to find the relation between, derive the relation between correlation and convolution between two sequences. Let us do that first. So we have got equation for correlation, we know if it is cross correlation, gamma xy of L is given by sigma over n equal to minus infinity to plus infinity x of n into y of n minus L. So clearly, cross correlation is nothing but comparing or correlating one signal with the time shifted version of another signal. Okay, one signal x of n with the time shifted version of y of n, I will give you gamma xy of L. Okay, so this is the expression for correlation. This is for correlation. And in the same way, we've already learned that convolution equation x of n convolution y of n is given by sigma over k equal to minus infinity to plus infinity x of k into y of n minus k. We've already learned that. This is a convolution equation. Okay. Now what we have to derive is a relation between this correlation equation and the convolution equation. Let us take the correlation equation gamma xy of L. And in this equation, we can see that n is a dummy variable. N is a summating or a dummy variable. So I can change the variable n to k. So we can write the equation as gamma xy of L is equal to sigma k equal to minus infinity to plus infinity x of k into y of k minus L. Okay. And I'm not gonna sit idle. I'm going to change further variable L to variable n. Now what we will get is that gives you gamma xy of n is equal to sigma over k equal to minus infinity to plus infinity x of k into y of k minus n. Okay, now a slight rearranging will give you sigma over k equal to minus infinity to plus infinity x of k into, I can write y of k minus n as y of minus of n minus k. Okay, now you compare this equation with the convolution equation. It's a very similar. We have sigma k equal to minus infinity to infinity x of k up to this is same. Now what is the next thing? Here it is y of minus of n minus k. Here it is y of n minus k. Okay, so the equation, if this equation was y of n minus k without a minus there, then that equation will be simply x of n convolution y of n. But we have a y of minus of n minus k there. So what will be the result? I can write this equation as x of n convolution, instead of y of n here, this is y of minus n. Okay, so what we have obtained is the correlation gamma of xy of n is x of n convolution y of minus n. So this is a relation we have to derive. This is a very important relation because if you want to find out the correlation between two signals, you find the convolution between first signal and a time folded version of the second signal. That's the derivation. Now the ensuing question is to find out the cross correlation between two signals given are x of n and y of n. X of n and y of n are given, and how will you find out the correlation? From this result we can use this result as gamma xy of n will be equal to first signal x of n convolution a time folded version of the second. And now we will see how we can do that. I would take this opportunity to explain another method of convolution, because we have already seen two lengthy procedures of how to convolve two signals in the previous questions. So this time I will give you a very simple idea how to obtain the convolution between two signals. That is, we call it as tabular method. The tabular method of finding convolution. So our aim is to find out the convolution between x of n and y of n using tabular method. So I am rewriting x of n is equal to sequence 1, 3, 2, 2, and y of n is sequence 1, 2, 3, 2. And since no arrow mark is given in the question, we can assume that first sample starts from n equal to 0. So the arrow mark at the first sample. Actually, we don't need this y of n. What we need is y of minus n. Okay, because correlation is actually x of n convolution y of minus n itself. So what is y of minus n? Y of minus n is flipping y of n about the y-axis. So this sample will be at n equal to 0 itself. Now this sample flips to this side at n equal to minus 1, this at n equal to minus 2, and this at minus 3. So what we will get is 2, 3, 2, 1. Okay, and 1 will be at n equal to 0. So this is y of minus n. Now we are going to convolve x of n and y of minus n. Okay, there is a very simple method for that, the tabular method. So what I'm going to do is I'm writing the samples of x of n in a column. So first sample is 1, then 3, 2, 2. Okay, similarly I'm going to write the samples of y of minus n, y of minus n in a horizontal fashion. So first sample is 2, 3, 2, 1. Okay, now what I'm going to do is I'm going to draw a table, okay, with these values. Okay, now I'm going to fill all these cells. What I'm going to fill at this cell is the product of this value and this value. Okay, 1 into 2 is 2. Okay, and what will be in this cell? It will be the product of 3 and 1. So 3 into 1 is 3. Okay, and I know what should be filled in this cell. It should be 2 into 1. 1 into 2 is 2. And here it will be 1 into 1 is 1. Okay, and similarly I'm going to fill out all the cells. So this is 3 into 2 6, 9, 6, 3. Similarly 4, 6, 4, 2, 4, 6, 4, 2. Okay, now my next step is I'm trying to diagonalize all these entries. That means the first entry I am drawing a diagonal so that I'm separating this entry. Okay, next I'm drawing a diagonal such that 2 more members are added. Okay, my next diagonal will be including 3 of these values. Okay, the next diagonal will be having 4 values. That's the maximum. Now the next diagonal include these 3 samples, the next diagonal these 2, and final. Okay, now listen, this is a very simple method because I'm directly going to the answer. So x of n convolution y of minus n, I'm directly giving the answer. The first sample will be the first value 2 itself. Okay, 2. First diagonal is having only 2, so 2 is the answer. Now what are the samples in the next diagonal? We have 6 and 3. Okay, so add 6 and 3. 6 plus 3 give you 9. So next value is 9. Okay, now consider the third diagonal. the sum is 4 plus 9 plus 2 will give you 15. Okay, the next bigger diagonal is 4 plus 6 plus 6 plus 1 will give you 17. Okay, next diagonal, the sum is 6 plus 4 plus 3, that is 13. Then 4 plus 2 will give you 6, and final sample only 2. Okay, so this is the answer, but we have one more duty left, because we haven't specified which sample starts at n equal to 0. So how can you do that? We have already learned that in convolution operation, if x of n starts at n equal to n1, if y of n starts at n equal to n2, then x of n convolution y of n, that signal will start at n equal to n1 plus n2. Okay, so here we are convolving x of n and y of minus n. Okay, so x of n starts at n equal to 0. So there is no confusion. So n1 is 0. Okay, now where does y of minus n start? See, the arrow is here. That means this is at n equal to 0. So one sample is at n equal to 0. So 2 will be at n equal to minus 1. I'm drawing n values. This is at minus 2 and this is at minus 3. So y of minus n starts at n equal to minus 3. So 0 plus minus 3 will give you minus 3. Okay, so our convolution final answer, this starts at n equal to minus 3. And this sample will be at n equal to minus 2. This is at n equal to minus 1. And 17 will be at n equal to 0. So we draw the arrow at 17. Okay, this is the final answer.